A phase hangs and times out, the box reboots under it, someone hits Control-C at the worst moment. Any one of those kills a run that has been building alone across 2 days. So how does it not lose the 2 days? It does not replan. It does not reread its own history. The entire memory of that run is one word on a disk and a commit saved on every build iteration. You have tried to make an agent run long, and you have watched what an interruption costs. The state of the work lives in the process, in the model's context window, in a queue that only exists while the thing is up. Kill the process and you kill the memory. On restart, it does not resume. It replans from the top, rereads what it already did, and pays for all of it again. Worse, it drifts. The second pass makes choices the first never made. This is the tax on every long, unattended job. Not the model, the absence of a place to stand after a crash. So you nurse it because a 2-day run you cannot interrupt is a run you cannot trust. The fix is not a smarter agent. It is moving the state out of the process and onto the disk. Everything I'm about to describe is one shell script, not a diagram of one. The actual file that ran these builds, no orchestration product under it, no vendor, no hosted control plane. The whole state machine is a loop, a variable, and a handful of small files, and the build loop commits its progress to version control on every iteration. That commit log is the receipt. Start with what is actually running. The overview, named a chain of 9 phases the build walks through, this is what walks it. Not a scheduler, not a state machine library, a while loop. The 9 phases run in a fixed order, so I am not rereading the list. I am showing you the thing that reads it. Inside the loop, a single variable holds the current phase, one word, build or security or docs. The loop reads that word, runs a case statement, and the matching arm does one phase of work. When that phase finishes, its arm sets the variable to the next phase. Then the loop comes back around. That is the entire engine. A while loop, one variable, a case, 0 frameworks. There is no scheduler deciding what runs next. The case statement is the scheduler. There is no task graph. People reach for an orchestration framework here on Reflex, a directed graph of tasks, a workflow engine, a queue with retries, and a framework you did not write hides failure modes you cannot see. They sit between you and a run you must trust while you sleep. Every one of those tools also hides the run state somewhere awkward, a database row, a message broker, an object graph in memory. The shell version keeps the state as one word. You can read it with your eyes and restore it with one line. When the whole position of a 2-day run is one variable, resuming is not a feature you build, it is just reading the variable back. The simplicity is not an aesthetic, it is the crash safety. So the loop advances on a word in a variable. Where does that word come from? Not from the agent announcing it is done. Each phase writes exactly one small JSON file, and the file says one thing: pass. The loop reads that file with a standard JSON parser and moves only on a clean pass. A silent phase never advances the machine. When a phase hands back anything else, garbled, empty, or missing, the loop has one written response. This phase did not report a valid status, treating it as failure, not a pass. That much is fail closed, and you have heard it before. Here is the part underneath it. The dangerous case is not a missing file, it is a stale one. Picture a phase that ran last round, wrote pass, then got kicked back to be redone. Its old pass file is still sitting on disk. Trust it, and the phase gets waved through on last round's result. So here is my favorite line in the entire pipeline. Before a phase runs, the loop deletes its own status file. It removes the old answer, does the work, then writes a fresh one. The read after that can only see this round's verdict. The build loop, the 3 checks, and the deploy each delete their own status file before they run. The loop does not just refuse silence, it refuses memory. It will not let a phase coast on a pass it earned an hour ago. Now, the other half of surviving alone. When the loop stops, something outside it has to know why. There is no human watching the screen. There is no dialogue to pop. So the run says why it stopped in the one channel a headless process always has. It's exit code. And these codes are a deliberate vocabulary, not an afterthought. Exit code 0 means the pipeline finished, every phase passed, the build shipped. Exit code 1 means it never really started. A bad knob, a missing tool, an empty ticket, another copy already running. Pre-flight, not the model's fault. Exit code 2 means it halted on purpose, and wants a human, it blew a cost ceiling or exhausted its passes, or it hit a status the loop could not read as a clean pass. Exit code 3 means the agent session itself broke, it crashed, timed out, or came back empty. And exit code 10 means it paused at a gate you told it to pause at. It is waiting for a human to say go. 5 codes. A cron job or a supervisor reads that one number. Retry this one. Page A person for that one. The exit code is the whole sentence. So exit code 2 is where the loop wakes a person. Most of the time, it does not have to. A failed check does not stop the run. It routes the work back to be fixed, then rechecks with no human in the loop. But that self-correction is bounded. The default cap is 3 rounds. Cross that bound, and the loop stops guessing. It halts with exit code 2 and hands the run to a person. That cap is the exact line. On one side, a machine that loops on its own. On the other, a machine that knows when to wake you. Watch it actually stop. A phase runs, writes its verdict, the loop reads it, then a kill signal lands, and the process exits with a number. That number, sitting in the shell, is the machine telling you exactly where it stands. No dialog box, no log to dig through. One number, and you know why it stopped. So now the whole thing pays off. Come back to the kill, the phase that hung, the reboot, the Control-C. What actually survives on disk? 2 things. First, a tiny state file. The loop rewrites it before every phase. A temporary file renamed into place, so a crash mid-write can never corrupt it. Inside are 3 values, the current phase, that one word, the pass number, and the running cost. That is the machine's entire mind between one moment and the next. Second, the code itself lives under version control, and the build loop commits after every single iteration, not at the end, everyone. So during the long, expensive build, the working tree always matches a recorded checkpoint. Now restart. The loop sources that state file. The phase, the pass count, the cost, all come back in one line. It logs where it is resuming from. Then it re-enters the exact phase it died in on top of the last commit, the last good step. It does not replan. It does not reread the whole history. It does not pay again for the phases it already cleared. It reads one word, lands back on top of the commit it already saved, and keeps going. A run survives a kill because it was never really holding 2 days in its head. It was holding one word and saving its work every iteration. So back to the question, how does an autonomous run built across 2 days survive a kill? Its entire state is one word on a disk, refreshed before every phase. That word sits on top of a commit it saved a moment ago. Kill it, and you lose one iteration, not 2 days. Here is your one action. Find your longest running automation and kill it mid-flight, then restart it. If it replans from the top instead of picking up where it died, its state was trapped in the process, not on disk. Move it there. Next, we open the loop the other way. It trusts a file, never the agent's word. So who writes the code and who is allowed to call it good? The org chart of 12 sub-agents, receipts, as always.